Welcome back, children. I'm Srinivasan here. We are going to discuss about concepts of functions. This is in chapter number 1, relations and function. Now, let us look at the word function. Function can be compared to a machine to easy understanding. What does a machine do actually? It takes some input, it processes and gives an output. Correct? The same what the function does. It gets an input. We call it the input as domain. Okay, you give the domain, the function processes the input and gives an output which is called as a range. That's it, children. This is what does your function do. It should be compared with the machine. You give input, the machine processes and gives the output. Take an example of a machine. We'll take a sugar cane. Okay, sugar cane, I'm giving it as an input. It's a domain. The machine makes the juice. Okay, squashes it and you're getting the juice. So sugarcane is the domain and machine is that function which processes and gives a juice which is the range. Okay, children, along with the juice you will also get some waste. Juice plus you have a waste, right? This juice plus waste can be compared as a codomain. Very easily you can understand. Which is important here? Juice is important, so range is very important. But along with the range, you may have waste or we may not also have waste. For example, take water. Okay, this is the input. This is the domain I am going to give. I am keeping it in the freezer. This is the actual function. I am getting the ice cubes. This is the range. Here we will not be getting any waste here. So here range and the codomain are the same. Range and codomain are the same. Such functions are called as one-to-one function. These sort of functions where range and codomain are equal are called as one-to-one functions. Or better understanding, we give a water, the freezer freezes, you get an ice cube. There is no extra. So these sort of functions are one-to-one. When range equal to codomain, you don't have an extra element, then we'll call it as a onto function. Here you have waste, right? This function is called as into function. These are called as into function. But in our syllabus, we need to remember one-to-one and onto. Okay, children, we don't have an extra element. Water is freezed to an ice cube, it's one-to-one function. Water is given, ice cube I got one-to-one. Onto function, why I call it as an onto function? Because I don't have any extras left. So range is equal to codomain, then we call it as a onto function. This is an easy understanding. Now we're going for a mathematical equations like thing. Okay, children, I hope you understood this. Okay. Now we'll take a function y equal to x plus 2. Okay. We'll give the domain, we'll give the inputs. X equal to 1, what is y? Yes, 3. X equal to 2, y equals 4. X equal to 3, y equals 5. Okay. So let us better understand using an arrow diagram. This is your domain. Okay. The domain is the input. What are the inputs you give? 1, 2 and 3. And here is your codomain. Why I am not calling it as a range? Range or the whatever outputs you get, it may be inside and you may also have extra, right? So 3, 4, 5. Here you got 3, 4, 5. So 1 with mapped with 3, 2 is mapped with 4, 3 is mapped with 5. Let us call this y as f of x. Because whatever you give it as an input, it processes, let the function be f. So f of x. So these sort of functions where the element is directly mapped with its one-to-one element is called as one-to-one function. Now we'll look onto the terms what are it's given. The element 1 has an image of 3. The element 2 has an image 4. The element 3 has an image 5. We can write this as f of 1 equals 3. So f of 2 equals 4. F of 3 equals 5. What do you understand from this? The image of 1 is 3. The image of 2 is 4. Image of 3 is 5. These are some of the technical terms. Okay. You don't have an extra element. So here this 3, 4, 5 are called as range. And here also we note that range is equal to codomain. And also we see no other element is left. So left in the codomain. So range is equal to codomain. We call it as onto function. So this function is 1 to 1 and onto function. Okay children, 1 to 1 and onto. I hope you understood the idea. Okay. Now I am going to make a little change in this function. Let us see what happens. Okay children, this is basics. Now we'll move on. Now I define this function as f from n to n, where n is a natural number. The set of natural numbers. What are natural numbers children? Yes, it starts from 1, 2, 3. In the lower class we studied, right? Goes to infinity. Okay. There is no negative number, no fraction, no decimals. These are the first numbers we studied in the school. So your domain is natural numbers and range, codomain are also natural numbers. Okay, so you have to read that the function f is defined from n to n. Okay children, let us go for that. Domain or the inputs, codomain contains the output. I cannot call codomain is the output, range is the output. Now let us, n is, you forgot about this one, n to n. So 1, 2, 3, 4, it goes on like that. Here also 1, 2, 3, 4, 5 goes on. Let us write 2 more. Okay. Right children, this is the input, this is this contains the output. You will not have a doubt in that, because you can have output or extras may be there. Now 1 to 3, I am mapping 1 to 3. Okay children, 2 to 4, then 3 to 5. So clearly it is a 1 to 1 function, because every element has only one image. 1 to 1 function. Okay children, now let us check it is an onto function. So starting from 1, you are able to map with every element. But what is the story of this 1 and 2? They are extras, right? They are left alone. So this function is not onto function. So clearly 1 is not an image of any element of the domain. Element of the domain. Now in books the domain is referred as capital X, codomain is referred as Y. Okay children, so 1 belongs to X. I can say 1 belongs to X is not an image of any element of the domain. 1 belongs to Y. Y belongs to Y is not an image of any element of the domain X. It cannot be mapped with. Okay, it cannot be. Same story is with your 2. 2 is not an image of any element. So such cases we call this is not an 1 to 1. Onto function. Not an onto function, because extra elements are there. Okay children, this is the idea behind 1 to 1 and onto functions. 1 to 1 means every element should map with an individual elements. Okay, and for onto function you have to see it from your codomain. Every element should be an image of some element of X in the domain. Then only you will call it as a onto function. I hope you have understood 1 to 1 and onto. Now we are learning some terms. 3 is an image of 1. 4 is an image of 2. Similarly, 5 is an image of 3. Okay children. Okay. 1 to 1 function. 1 to 1 functions are called as injective functions. These are terms I am telling about. Onto functions are called as surjective function. and this both one-to-one and on-to functions are called as one-to-one and on-to functions are called as bijective functions. That's it, children. Injective one-to-one, subjective on-to functions, bijective is one-to-one and on-to functions. Okay, children. One-to-one and on-to functions only will have a inverse. Other functions will not have. It should be one-to-one and no element should be left behind, no extra elements in the codomain. That means range should be equal to the codomain, then only the inverse exists. For example, I say 1 has an image of 3 if you don't have this one. Your range and codomain is same. For example, I am telling you 1 is having an image of 3, correct? 2 is having an image of 4. So every element is an image of x. So it is 1-to-1 and on-to. Then you can find what is the image of 1 is 3. What is the pre-image? What is the inverse of 3? Or the inverse of 3 is 1. Inverse of 4 is 2. Inverse of 5 is 3. It is possible to map like that, and that is in your exercise 1.3. Okay, children, this will help you to understand 1.2. You will be able to 1.2.